I will explain how to properly wire the outdoor unit's circuit board, because I have often seen that some people make mistakes while wiring, which can damage the unit. So I will show you where and how to connect each point correctly. First, I will show you how to remove these connectors. Often I've seen people trying to pull them out forcefully, but no matter how hard you pull, either the PCB will break or the connector itself will get damaged, but it won't come out. The reason for this is that there's a lock inside the connector, which I will show you shortly. But first, let me show you how to properly remove it. Take a tester or a flat tool, place it over the connector, and press it down gently. This way, the connector will come out easily. If you don't use this method, it will not come out no matter what you do. So you can see this thimble here. This is an angled thimble, whereas the previous one was a straight thimble. That's the only difference. Otherwise, there's no other variation. You can see that it has a lock here. When you press it, this part gets pushed in, and the point in the center shows that there's a lock inside. When we press it, the lock moves backward. Let me show you from the back side so you can understand better. You can see that when I press it, the lock moves backward. If the lock is engaged, the thimble won't move from its position. That's why you need to press it to release the lock. Now you can see that I've separated all the wires so that I can explain to you how to make proper connections. The first and most important thing to do is identify which wire goes to which point. In higher ACs, most of the time, the wires used are black and white. Now, what do these wires signify? The white wire is the neutral wire, while the black wire is for the phase or line. Additionally, let me explain that the power supply flows from the outdoor unit to the indoor unit. The main supply comes from the breaker, enters the outdoor unit, and then goes to the indoor unit. You can see here that there's a complete filtering system for the indoor unit. The electricity is filtered here before being sent to the indoor unit. If the manufacturer specifies that the supply should first go to the outdoor unit and then to the indoor unit, you should follow that method. This ensures that the unit operates efficiently and properly. Now, an important point to understand is about the communication wires. If these communication wires are connected incorrectly, it can cause significant issues, which I will explain. You can see that the marking on this wire has faded. The third wire here is labeled 3C, and it typically has a red sticker on it because the wire itself is red. This is the communication wire. The company has provided a separate connector specifically for this wire. Let me show you by removing it. You can see it's a proper connector, and the neutral and phase are provided on the same point. The neutral is connected using a white-colored wire, which is common at this point. If this connection is missed, or the connector is not properly attached, the communication will not work, and the unit will show an E7 error. First, let me explain that this is a proper connector, and it will fit into connector number 38. Once it is placed correctly, your communication setup will be ready. Now, let's discuss the main supply. You can see that the main supply wires come from this small connector. These wires are passed through a ferrite core for filtering purposes. After that, the connector clearly shows its labels. A common mistake I've seen many people make is that they don't connect the line-in wire to the correct place. Instead, they mistakenly connect it to one of the two line-out points, which are located here and here. This causes errors and damages the system. To avoid this, always ensure proper connections. For the neutral, connect it to connector number 1, and for the line, connect it to connector number 2. With this, the main supply connection is properly completed. Next, let me explain the connections for the indoor unit. The power for the indoor unit goes through a proper filtering system. After filtering, it is sent out to the indoor unit. You can see the wires here. Neutral 1 and L2 are labeled accordingly. These wires must be connected properly to ensure correct functioning. For this, connect them to connector number 6 and 7. The AC line will go to the line terminal, and the neutral will go to the neutral terminal. With this setup, the indoor unit connections are also completed properly. Now let's discuss how to reconnect the wires inside the PCB if you've removed all of them. Focus on connector numbers 9 and 10, where the PTC sensor is located, the black component. Additionally, I'll show you the AC neutral out and AC line out terminals. The company provides separate wires for these connections, which must be properly inserted into these connectors. Once done, this connection is complete. This section directly connects to the IPM Intelligent Power Module, which is responsible for starting the compressor. The power PCB has its own separate system, meaning you can power the PCB directly if needed. If you supply electricity to the PCB, it will start. However, note that LED 1 will glow, indicating power to the PCB, while LED 2 will not glow, because it is linked to the the IPM system. This confirms that the connections are correctly established with the IPM. Now let's proceed with the IPM connections. The terminals labeled L1 and L0 are for the reactor wires. These wires connect to the reactor, and it doesn't matter which wire goes to which point, as both have the same function. Once these are connected, the reactor connection is complete. Next, we move to the line and neutral connections, which I explained earlier. The AC line and the AC neutral points are labeled on the PCB. Connect the black wire to the line terminal and the white wire to the neutral terminal. After that, we need to provide DC supply because when the main supply enters the system, it goes through rectification. The power flows through the reactor and then into the PCB. The yellow wire connects to the P number terminal, while the blue wire connects to the neutral terminal. These have their designated points on the PCB. The 3 central points on the PCB remain unconnected at this stage, as they are reserved for the compressor UVW points, which will be connected later. This completes the IPM connections. Now, look at the communication wires connected here. Each has its designated connector. The black connector will go into the black socket, and the blue connector will go into the blue socket. With this, the communication connections are completed. Let me also point out an important detail. You can see that there are separate connectors for the earthing wires. One customer once brought me a PCB where they had mistakenly connected the neutral wire to the earthing point. This is incorrect because the earthing wire is meant to be installed wherever you see PE written, along with the earthing symbol. Never connect the neutral wire to these points. Only the earthing wire should be connected here. Now you can see that the PCB is installed in the unit, and I want to show you how to connect the compressor wires properly. The red wire is connected to the W terminal. The white wire goes into the V terminal, and the black wire is installed on the U terminal. This arrangement is essential, so make sure you don't forget it. Now let me explain how to make proper connections. The wire colors might be slightly different here, but this is how we've installed them. Let me clarify for you. This is the main supply wire, and you can see the terminals labeled line and N neutral. The supply coming from the breaker is connected here. Next, the terminals labeled 1 and 2L are for the indoor unit supply. Finally, the terminal labeled 3C is for the communication wire. This is how you need to make all the connections systematically to ensure everything works as intended. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.